Texas Math Mundo audience, let's do some math. Today's topic is defined operations. These are really fun problems. My students, of course, oftentimes the UIL competitions are the first time they're exposed to problems of this sort. Once they get comfortable and used to them, they really start to enjoy them. There's a lot of fun. I want to make sure that I take a moment to thank UIL for the permission they gave me to use their problems. Today we'll be looking at 4 problems. We'll be looking at number 23 from UIL A in the year 2021. We'll be looking at number 23 from UIL B, the year 2020. We'll be looking at number 59 from District 2, the year 2015. And we'll be looking at number 46 from UIL A, the year 2010. There's some variations on defined operation problems I'd like to look at. It should be a lot of fun. Let's do some math. I just want to take a moment and say, if you enjoy this sort of material, please hit the subscription button and the notification bell, smash that like button, and leave a comment below. My name is Saul Cantu, and this is Texas Math Mundo. Alright, Texas Math Mundo audience, let's do some defined problems. So the first example we have, defined operations problems. The first example we have is kind of unique because it's a defined unary operation. That means it operates on one operand. This is district number 2, number 59 from the year 2015, UIL. Once again, let me be very thankful to UIL for letting me use their problems. I really appreciate that. So this problem comes from the district 2015, district number 2, number 59. And the problem reads, ND Dark needs help solving this problem. Let circle plus n circle plus be the largest prime factor of n, and let circle minus n circle minus be the smallest prime factor of n greater than 1. What does circle plus 20 circle plus minus circle minus 15 circle minus times circle plus 49 circle plus circle minus 57 circle minus? Alright, so this is interesting. Since these are made up operations, or at least defined operations, it's hard to know how to read it correctly, but did my best. Okay, so let's go. So when the operand is surrounded by a circle plus, we are supposed to get the largest prime factor of n, and when it's surrounded by a circle minus, we're supposed to get the smallest prime factor of n greater than 1. And then we're going to adhere to order of operations. So if we look at our expression, we're going to go with the circle plus 20 circle plus. That one we need the largest prime factor. 20 factors into 2 squared and 5. So the largest prime factor is 5. And then minus. And then the smallest prime factor of 15. 15 factors into 3 times 5. So the smallest prime factor greater than 1 is 3. Times the largest prime factor of 49. Since 49 is just simply 7 squared, that would be 7. Plus the smallest prime factor greater than 1 of 57. Well, 57 is 3 times 19. So the smallest prime factor greater than 1 is 3. And now it's a simple order of operations problem. The multiplication has to happen first. So it's 5 minus 21 plus 3. And 5 minus 21 is a negative 16 plus 3. And the answer is a negative 13. There we go, negative 13, A. So this one's a kind of unique one in the sense that this is a unary operator defined. And this again comes from the UIL district number 2 from the year 2015, number 59. Okay, let's go on to another one, a more traditional binary one. All right, Texas Math Mundo audience. Our next problem is from the year 2010. It's UIL A, year 2010, problem number 46. And this is a defined binary operation. It says the operation triangle is defined by A triangle B is equal to A raised to the B minus B raised to the A. What is the value of 0 triangle 1, triangle 2, triangle 3? So, the way we're going to do this is we're going to go to work in the parentheses first. 0 triangle 1, triangle 2, triangle 3. So working on the left-hand parentheses, I have 0 raised to the 1 minus 1 raised to the 0. I'm going to keep that in parentheses as I work. Triangle, and then it's 2 raised to the 3, triangle, 3 raised to the 2. Alright, so 0 raised to the 1 is just 0, and minus 1, so it's a negative 1, minus 1 to the 0, and 1 to the 0 is 1, so it's negative 1. So we're going to have negative 1, triangle, and on the other side, oops, I should have put a minus 3 squared. Okay, I just erase that triangle. And it's actually minus 3 squared. There we go. And 2 to the third is 8, minus 3 to the 9. 3 squared is 9. 8 minus 9 is a negative 1. And so we have a negative 1 triangle negative 1, which is negative 1 raised to the negative 1, minus negative 1 raised to the negative 1. And we have a 1 over negative 1. Or negative 1 over 1, minus a negative 1 over 1. So that's plus, and I have a negative 1 plus 1, and that reduces to 0. And the answer, I got the number 0, and the answer is B, 0. All right, so that's a binary operation defined. Many of my kids, the first time they're exposed to this stuff is in UIL competitions, so they're not familiar with it. But once they get familiar with it, they start to get comfortable with these type of problems, and it turns out to kind of be on the easy side. All right, now those of you who are saying this is 2010, what am I doing with the problem from 2010? Well, let me show you a problem from 2021. All right, so why study a problem from the year 2010? Well, first of all, it's all good mathematics, no matter what year it is. All very beautiful and good mathematics. But this is number 23 from UIL A from the year 2021. This is last year's UIL A release, number 23. So these problems pop up again. Again, this is exactly defined like the one from 2010. I'll leave this as an exercise to you. I just wanted to show you that these problems are good. They're timeless. They're timeless problems, and they're always good exercises and fun to do. Okay, so let's do a final problem. All right, so the final problem I want to look at is an interesting variation on defined operation problems. And I had to take a look at this, and I got lucky. I saw the pattern right away. But I'm not so sure what the absolute correct approach is on this one. Number 20, this is number 23, UIL B, the year 2020. Again, UIL B, the year 2020, problem number 23. And they have a defined operation, a little variation on it. They give you some inputs and outputs, and they ask you to find 2 operation 8. So they have a 5 circle dot 2 is equal to 13. 3 circle dot 3 is equal to 6, 2 circle dot 4 is equal to 2, and 2 circle dot 8, what's that equal to? So again, 5 circle dot 2 is equal to 13, 3 circle dot 3 is equal to 6, 2 circle dot 4 is equal to 2. What is 2 circle dot 8 equal to? So I don't know about the formal way to do this. I saw immediately that 3 times 5 minus, so
I saw immediately that A circle dot B would equal to 3 times A minus B. So 3 times 15 minus 2 is 13. 3 times 3 is 9, minus 3 is 6. 3 times 2 is 6, minus 4 is 2. So 3 times 2 is 6, minus 8 is a negative 2. I saw that immediately. I don't know if it's just requiring you to have good pattern recognition. I suppose you could assume a linear combination, and then with 2 points you can find out your A and B. That's possible. If you assume a linear combination, we'd have 5A plus 2B equals 13. And then we'd also have 3A plus 3B is equal to 6. And then you could solve for A and B. That would give you with that would end up with A equal 3. A equals 3 and B equal -1, which gives us our rule. But I'm not so sure exactly if there's a definitive foolproof way to do this. I saw the pattern immediately. I just thought this was a very interesting variation on defined operations problems. Okay, that's my treatment of defined operations. I hope you enjoyed that.
I really hope you enjoyed that. It's fun. If you know a better way to do these problems, or you see somehow that I was inefficient in my approach, please leave a comment below. If you have any additional insight into any of the problems, please leave a comment below. Also, if you'd like to see me do a particular problem, please mention it. You can email me or leave a comment below, and I'd be more than happy to do an old UIL problem that you may be interested to see if there's a more efficient way or some way to approach it. I hope you enjoyed it. It's a lot of fun. Let me take a moment and tell you if you enjoy this content, hit the subscription button and the notification bell. Smash that like button and leave a comment below. Thank you very much for your support. I really appreciate it. My name is Saul Cantu, and this is Texas Math Mundo.